Cutting-edge RL with Impala and Unreal, using importance sampling with Retrace Lambda. Importance sampling is a general technique for estimating expected values under one distribution, given samples from another. It is used in off-policy methods to weight returns. Importance sampling is represented as a ratio of a target policy divided by a behavior policy. This ratio is multiplied by the return to correct for how off-policy the behavior policy is. The agent generally collects experience with the behavior policy and updates the target policy. Importance sampling can suffer from large variance due to the product CS. Retrace Lambda can be seen as an algorithm that automatically adjusts, efficiently and safely, the length of the return to the degree of off-policyness of any available data. Retrace improves upon similar off-policy methods like importance sampling, Q-lambda, and tree backup lambda. The main benefits of Retrace are the low variance and better usage of off-policy and on-policy data compared to those methods. Retrace truncates the variance at 1, thus avoiding exploding variance. Truffle.retrace calls Truffle.retrace core. Truffle.retrace makes calling Truffle.retrace core slightly easier by lining up the sequence dimensions of the inputted tensors. Using Retrace core follows the three main steps of truffle usage. The arguments should look familiar by now, except for the target and behavior policy inputs. The target policy inputs are the probabilities of the policy the agent is learning. The behavior policy inputs are the probabilities that the agent is acting under when interacting with the environment. The first two dimensions of these inputs are the sequence length t and the batch size b. When inputting these arguments into Truffle, note that the target policy has an extra dimension for number of actions. Truffle.retrace is a convenient wrapper that calls Truffle.retrace core. The Truffle code uses 2 lines of code on the slide to gather sections of the argument tensors before inputting the tensors into Truffle.retrace core. In the documents, the Truffle.retrace input tensors have a dimension t+1, which this code helps explain. Truffle.retrace only returns the loss, while Truffle.retrace core returns the loss, target, and retrace weights. For the code in this section, we'll use Retrace Lambda to play the taxi environment. Let's look at some code. In the taxi environment, the yellow taxi moves to pick up the passenger at the blue location and drop the passenger off at the pink location. Here we set up the Truffle.retrace core tensor. Most of these arguments are similar to the Lambda methods from last section. We have new placeholders for the target and behavior policies. We have some simple functions here to generate the target and behavior policies. The two policies are different, and we use Retrace to correct for the off-policyness of the behavior policy. In the RL loop, we generate the policies based on the Q values and shape them accordingly, before inputting them into the Truffle tensor. Here we see on Retrace core we have to slice the tensors to cover the correct sequences. These tensors go from 0 to t-1. These tensors go from 1 to t. Truffle.retrace performs this slicing for you. Here we run the retrace tensor and use the target return. We use this target return to update the Q value array, as we did in the Lambda videos. Further resources.